In this article, we'll be going through this Medium article I wrote a couple weeks ago. I wanted to create a video for it because some people just prefer consuming content that way, and there's a lot of steps here, so I wanted to kind of walk through them visually, so if people got lost, they can follow along with the video. So one of the main things you might ask is, what's different about this from Exist? It's kind of summarized here. There's obviously documentation on creating .NET services. There's documentation on Java, on what OpenAPI is, on Azure Devops pipelines, on Node and React and all that stuff. But they're all kind of separate. And so this article kind of brings them all together in what I talked about, creating a really good developer, a much better developer experience. When you think about if you update your service API and then you have to manually update it to match that API, that's pretty tedious. You can also make mistakes. So we're going to see how to fix that using kind of automating almost the whole process. You still have to account for breaking changes, but that's always the case. So yeah, I will walk through the commands here. So first we have to create our folder. This is going to be a monorepo where we have a client and a service and the generated clients. Let's open up our terminal. So here I have it set to my repos folder. We are going to create a new directory for our monorepo. Because I've already done this, I'm just going to add a 2, but I will fix that later. So now we're going to scroll down the article to create the service. So we'll make a directory for the service. Make a solution. So here we are creating a new project in that solution called Articles API because we want to create an API mimicking articles. Again, not very creative. I was just writing a Medium article and thought, why not create a Articles API. Cool, so this uses the default .NET template, which includes Swagger, and we'll look at that later. So now I need to add that project we just created to the solution. And then we'll finally add all of that. Okay, so here we've just made our first commit. We've created the monorepo folder called .NET OpenAPI Node 2, and we've created a service folder inside that with a .NET solution and one project. And we can go ahead and open that project to see it working. So open Visual Studio, and we'll try to find that folder. So here's the Articles API. By default, it comes with the weather forecast controller and just outputs. We'll run it real quick and see what the template does. It's great that it already includes Swagger. So as I demonstrate in the article, so by default, Swagger generates a UI based off the Swagger definition. We have one endpoint weather forecast, and we could try it out. But as you know in the article, we're going to change this to do some operations on article objects. So I will spend some time to change all the files to make the Articles API. Alright, so here you can see we've updated the service to the Articles API. We've added or swapped the weather forecast controller out for the Articles controller. It has a similar just in-memory list of articles. So every time I reset the server, this is going to reset the state. But it just allows some basic operations, get by ID, create, and then in the program, we added some other things to lowercase the URLs, allow cores, and if we run it, we can see our new, the Swagger UI will reflect our updated articles API instead of the weather forecast by default. So we can see here, we can get articles. So one more thing you can notice when you're looking at the Swagger UI, if you click this link, you'll actually get the Swagger JSON file. This is a specification of the entire API, and this is what is used to generate clients. You can see it specifies all of the endpoints, and for each method on that path, we get an operation ID, a response code, and it specifies the schema of that response, which is going to be an array of articles. And it continues for each of the endpoints, methods, and types. So now that we have the service, we have to create the React application, which is going to consume this API and display the articles and allow creating articles. So let's do that. And open up our terminal again. So now I need to create the client. And as I mentioned here in the article, I later realized client was a really bad name for this, just because we have the service, the client application, which is consuming the API, but then we also have client libraries, which are just something the client application consumes to make HTTP requests to the endpoints, and sometimes I shorten it to say client for the application or client for the library, and it can be kind of confusing, but just remember to keep those straight. All right, our client application is created. If we go into it and run npm start, you'll see it loads up the default React template in the same way that the .NET CLI generated a default application. And we will also have to do work to change that to consume our articles API. And again, I will speed through that process. Alright, so here you can see the default application created by the create React app initiator. And again, we will have to rewrite this to use our articles API to look like the article. So I will do that. So here we have updated the default React application to use the articles API. You can see we have a component with a list of articles, and we have some form and on-change handlers so that when a user enters a title and body and clicks submit, we create an article object and then post it and add it to the list. And important to note that this post comes from a manually generated client. So we know the endpoints that exist in our service based on the Swagger definition, and then we can write a client to work with that manually. But this is the problem we're trying to avoid. It's because every time someone changes the service, they would also have to change the client, and we're trying to automate that process. So this entire client file will get replaced by generated code from the Swagger definition. Here we can create a new article. And it gets added to our list, as you would expect. And we'll just say another article. And if we want, we can even put a breakpoint in our service and see it work. So we hit this breakpoint, we have our article object, and we are going to this is your basic client server setup. And so what we're going to now is generate the client library instead of handwriting the client file. So let's go back to the article and see how we do that. So now we want to figure out how to create the Swagger JSON file programmatically. We did see that it was available when the service was running, but we want to be able to generate it using the CLI so that we can do this during the build pipeline. So we'll go to the service directory and we're going to use the Swagger CLI tool. So we're creating a new tool manifest. You could use a different version here, but because the default ASP.NET Core template defaults to 623, we're just going to use 623. Alright, so we can see we've successfully installed the Swagger CLI tool. So now we should be able to test the generation of the Swagger using this command. We can see we can generate the Swagger file using this Swagger CLI. So now we have the ability to generate a Swagger file. Now we're going to generate a client from that Swagger file. So first we have to download the OpenAPI generator tool. So we'll paste that command in. So I have this file Typescript generation config JSON to specify some of the options. I think the minimum you need is the name, and these other ones configure the generator to output different code. If you want to see all of the options, you may use this command, and you can see it outputs all of the settings you could put in that configuration file, but we don't need them for now. So now comes the cool part. We can attempt to actually generate the Typescript client. So you can see all this output. It has some warnings, but it did generate the client. And in this VS Code, we can go back and look, and we have the source, we have all the models, we have the article input, and we have a client build for us, which makes the HTTP requests that originally we were manually writing in our service. As I point out in the article, this is a pretty big step to be able to programmatically generate a client from a Swagger definition. So you can imagine all of the applications out there in the world that are using RESTful HTTP endpoints that could be specified by documents such as the Swagger or OpenAPI specification, and being able to programmatically generate them and consume them in many different languages makes it much more portable and decreases the cost of using that API. So now that we've generated the TypeScript client, we actually have to make this client usable in the consuming applications. So the generator just creates these source files. First we have to install dependencies, and then we have to use this command called npm link, which basically simulates publishing it to a remote, repository like npm or GitHub, but publishes it locally. So if you had done npm install g, install the package, it basically puts it in that location and makes it available to be used. And then we'll see there's kind of a pair between how you link. You generally link a package to make it available and then link it into a project as opposed to installing it. One more thing you might notice is that it's pretty tedious to have to go to the service, generate the Swagger, download the OpenAPI generator tool, run all the commands to generate the client, install the dependencies, and then link it. So one technique is to actually automate even that step. So you can create a new PowerShell script here that basically takes some inputs as the version and whether should it run the linking or not, and that it, knowing the origin is the client generation directory, it does all those steps. It builds a service, make sure the Swagger CLI tool is available, generates the Swagger, and then if the generator's Java file is not downloaded, it downloads it, then generates a Typescript client, and then if you want to install, it installs dependencies and links it. And so if you run that, it will look like this. Which basically does all of the steps we just did manually in a script, which is very nice. All right, so now that we've installed the client dependencies, we have to, and linked it to make it available to other applications, we have to go into the application we want to consume it in and run link again. And this creates a symbolic link between the actual source and here. So the client application thinks that it's installed, but it's not really. There's more documentation on npm link if you're interested in that. So now if we open up our client application, that has been rewritten to use the client library we just generated. We see that we can reference that library. And instead of implementing all of the methods to, get an article, post an article, or get an article by ID, we can simply create one of these objects, and then inside the app.ts here, where we were using the client, we originally were calling post article. Now we're calling articles API create article, which does the same thing, but it uses generated code. So if we step into this, we can see this class is auto-generated by API generator. This is great. And even better, let's run the application to make sure it still works. And you can see that, yes, it still is able to fetch the articles. It even has those two we created because we haven't shut down the service. And we can try generated client article. Oh, still have our breakpoint set. Can get rid of that. Yeah, so even this new article works using the generated client. All right, so if you've been following along, we have the React application using the generated client library to access the articles API, which is great, but we still have a few outstanding issues. The repository setup is still a little bit complicated. Because we're using npm link, it means we don't actually specify the dependency in the React application. So if someone were to clone this repo, it wouldn't work off the bat. They would have to understand npm link, know how to generate the client, and do all that stuff. It's much easier if they have a very traditional just npm install and run, which is what we want. The other problem is we are hard-coding the packet version when we're running the generation scripts as 1.0 local. This is fine for all local development, but when we actually deploy, we want incrementing package versions. So what is the solution to these problems is to automate it again using the Azure build pipeline. So we'll basically build and test the server, generate the Swagger JSON, generate the client, test the client works, and if it passes, publish this package, and then update the application to use this package and commit those changes back to the repo. So let's see how to do that in Azure DevOps. So we have to create a new project. So here I am in my Azure DevOps. So I'll create a new one. So again, this already exists. So I'll add a 2. So first we have to actually push our code into this new project. Now we have our code in this ADO project. Now we need to add a new pipeline. So we'll go to pipelines. So here we've created our pipeline. We've put in our initial pipeline code, which you can see here, which is going to do all these steps. We can see the pipeline running. All right, now that our pipeline has finished, we can see all of these steps were successful. You can see a lot of time was spent downloading the OpenAPI Java package archive, and then a lot of time was spent installing npm dependencies. So next we will add caching so that this is saved and can be restored very much more quickly. So if you look at the documentation for Azure DevOps caching, you can see one of the main concerns is what you use as the key for the cache. It could be the hash of a file, a hard-coded string, or a combination of things separated by this pipe operators. And for the OpenAPI generator, we can just use a static string, but for some of the other things like npm dependencies, we actually care about the package.json. So also I have to be worried about the conditions when the scripts that are run if cache is restored or not restored. For instance, if the cache is restored and we assume we have the generator in there, we don't need to run the command to download it. So we will use these variables to control that. So here we can look at the commit which added caching to the pipeline. So you can see we added caching to the OpenAPI Java archive, and we set this cache hit OpenAPI CLI if it was successful, so that we know to skip the steps to create the download folder and download the generation tool if it was restored. So then we also add caching for the Typescript clients and the client application based off the package JSON. So the next step is to publish the generated TypeScript package, and in order to do that, we have to use incrementing versions because you can't publish the same package twice. And so we have to make some changes to our pipeline. If you remember before, the version was hard-coded because we were always running it as 1.0.0-local, but now we need to make it based off the build number. So Azure has some special properties in the pipeline that allow us to do that. So in our project, Azure DevOps has this section called artifacts, and this will act as the feed which we're going to store packages. So you could publish to GitHub or npm, but because everything is on Azure DevOps, we'll just continue using this for demonstration. It has the ability to have private packages, which you might want. Currently, ours are public because our project is public, but we'll create a new package feed, not .NET OpenAPI Node, just as copying the project name. And you can click connect to feed, and we are going to use npm, and you get all these instructions here. So follow these. You have to install the VSTS npm auth package, which VSTS is the old name for Azure Devops. It used to be Visual Studio Team Services, but they have rebranded it. We also have to create an npm-rc file, and this with this contents, and it allows npm to know that for the .NET OpenAPI node package, or packages with this prefix, we want to use that custom registry instead of defaulting to npm. So you also have to set up authentication to your package feed. So the npm auth generates a token and saves it in the appropriate place for you. And then we have to update our build to have the same thing. So we can look at the build commit here. So here's the changes we made to add package publishing to the build. So you can see we added this variable that has a generated incrementing number for the package version. Then we use that number in the generation script. Then we authenticate, which does the same thing as that VSTS npm auth locally, but does it during the build. And then we run npm publish to publish that packages with the .NET OpenAPI scope to our private feed. So on this step, we have the build generating a package using a unique version and the ability to publish that package, but we need it to also update the client to use the package it just published and commit it back to the repo. And this is a little bit tricky because there's that setting. You don't normally want your builds committing to your code, but this is a special circumstance. So there's a couple steps involved. First, we have to find out how to get the generated package version. So we'll have to use some regular expressions to get that. Then we'll also have to save it to a variable in the pipeline so that we can use it in different commands. And you can see the results here. And then we have to change the permissions of the account that's running the build to be able to commit back to the repo. So we'll go do that. And also we need the build to check out using and maintaining the credentials it has. So we need the build to be able to commit back to the repository. So we need the build to persist the credentials it uses to check out the code. We need to know we only want to commit on main branch, so we need some extra variables and logic to determine if we're on the main branch, if this is something that has been merged or not. And then we also have to give that account permissions to commit back to the repo. So, all right, so we'll click the organization, go to organizational settings, click projects, we'll access that new project I created for this video. Then we'll click on repositories, security, and we'll select the account that the build service account down here that the builds run under, and we need to give it permissions to bypass policies when completing pull requests, bypass policies when... Alright, so now our build has the correct permissions. Let's go look at a full set of changes to the pipeline. Because we've given the build permissions, now we can write a script that actually uses Git. In order to do that, we have to configure the username email. We want to add the changes we made to the package files, and then commit it back. And I'm using the conventional commit syntax here, which uses the skip CI so that it doesn't cause an infinite loop of pipelines where The pipeline is triggered off commits, so when we commit, it's going to trigger again. So we always make sure the pipeline skips this trigger. And in order to prove that everything worked, we'll go ahead and make a simple change. So I will add a URL segment to this get path. So we've added this get all articles path segment to the endpoint, which gets all of the articles. It's really redundant, but just an example. And so normally this would have been a breaking change. We changed the path. So our client, which is trying to get articles, would try to fetch something that is no longer found. So we'll see how our pipeline and generation have kind of absorbed this, so it's no longer a breaking change. So we'll see we have this change. We'll add get all articles to URL, and we'll push this. So here's the build that ran after we added the path to the endpoint. And so this one was merged and running on main branch. So it runs all of our steps. So you can scroll down to the part that changes, and we have added off to the Typescript client, published that package to our private feed. We've gotten the package version number that was used or generated by the build, and then we use that variable to install that package into the client. You can see here, and we verified it by printing out. We can see it again in the client, and then we created a commit of the changes to the package and package lock JSON. Okay, well, this was quite a long video, and there was a ton of steps in here. We touch many different technologies: OpenAPI, generator, TypeScript, Node, Java, everything from ADO, setting permissions, build pipelines, YAML. So there's a lot here. I hope you learned something, and this was helpful. So let me know what you think in the comments. Thanks.